All right, welcome back, camera. So today we're doing sentences to equations day 2. Now I just need you guys to realize something. Your video is on YouTube. I have 2 algebra groups. I have this group, which is the normal pace, and then I have 1A, which is a slightly different pace. So they get a little more lesson detail than you guys do, maybe a few more examples. So if you feel like you're still struggling with something and you see a video that doesn't appear to be one that was in my class, it's because it's, or this class, it's because it was a 1A video, which totally means you can still watch it. It's in your folder, okay? And it might be more detail. It might be just the thing you need. All right. So example 5 is where we're going to start. Choose a variable to represent, write an equation that gives the information. All right. So really quick, we know that we're doing, in example 5, I'm going to give you my own, but I'm going to do the same. We're going to do a distance is equal to rate times time sort of a problem. Okay? Distance is equivalent to rate times time. Where's my sample? Okay, so here's what they give us. My example is this. The plane flew 12 hours. And this is going to be designed to be very simple. Hold on. And went 4,800 miles. Miles. We're not going to use kilometers. Miles. So, 3 items are required for distance equals rate times time. But if you have 2 of the items, you can solve for the one you don't know. Within this mess, which 2 items do we have? What do we have? Distance, I hear distance, and what else? Time. So if I have distance, I plug it in where distance goes. And I don't have rate, but I do have time. Normally you're going to see it written like this, 4,800 equals 12R. You'll rarely see a variable in front of a number. Okay? The number preceding a variable is the coefficient. 12 times whatever the rate is equivalent to 4,800 miles. Okay? Remember, we're not solving anything. Okay? This lesson is still slowly clawing through the fact that you're setting these up. Okay? This is example 5. Now, to get you prepared for the rest of this assignment, we're going to go over as many of page 22's odd 23 through 33. I do not intend to do all 11 with you. I'll do as many as it seems like we need to do, okay? So stay with me. If you are a super duper expert at this, fantastic. But still, there's always something you can learn extra, right? Okay, starting with 23. The perimeter of a square is 1/16. So this is number 23. How about 23? Perimeter square is 1/16. They want to know the length of a side. And while you could easily go to the back of the book and look up the answer, rather than do that, we're going to discuss something about a square. What do we know about a square in relationship to the side size? Go ahead, Samaria. Amen. They're all the same. So whatever this is, there are 4 equal sides that when added together give us 116 units, inches, I don't remember what it said, meters. Okay? So this, my friend, would be the answer. Okay, because the perimeter of a square is simply the sum of the sides. Now, rather than write s plus s plus s plus s, just multiply it by 4 because it's all the same anyway. Any questions on that one? Not too shabby, right? 25. Okay. If there was ever something that I thought was tedious and annoying within word problems, you guys know I like word problems. Number 25 is one of those things that I find tedious because I still literally have to really think about these so that I don't accidentally add when I should have subtracted or vice versa. So 7 years from now, a coin will be 50. Okay? A coin will be 50 years old. So tell me what you think the coin is now. Give me a variable to represent the coin's age. X, C is perfect. So right now, the coin is C years old. If I go ahead by a certain number of years, it's C plus 50. Okay? I'm sorry, C plus 7. Shoot. 7 years from now. Sorry, C plus 7. 7 years from now. C plus 7. So the equation is C plus 7 is 50. Okay? The age stuff, they might do problems like 20 years ago, a bridge was such and such. Those kind of problems, those age problems, and being able to figure out if it's more or less, oftentimes require me to pause and do something with my own age and use your own age. You guys have a smaller number than me to try and figure those things out. Okay. Hoo-wee. $27. A store sold all but 12 out of the shipment, which totaled 120 books? 120 books, right? So I can say the total is 120 books, right? What did it sell? Any variable ideas? B. Books. But it didn't sell all the books. How many were laying on the bookshelf after the big sale? 12. So these were the amounts sold. These were the leftovers. And this equation would allow you to solve. Oh, so annoying. Would allow you to solve if you wanted to, okay? Yes, I know. You sold 108 books. I get it. Okay. 29. 1/8 of a pizza sold for 95 cents. Anybody find that one annoying? Yeah. So I'm doing something like this with the 6th graders, and it just cracks me up that you guys have to do this. But okay, we'll do it. So this is it. 1/8 of a pizza sold for 95 cents. 1/8 of a pizza sold for 95 cents. No. 1/8 of pizza costed 0.95. I did, and I didn't mean to. I ain't gonna correct myself. 1/8 of the pizza cost 95 cents. There's 2 ways to go about this, but using variables. You have to have a variable. Costs 95 cents. How do I indicate 1/8 of a pizza using a variable? 1/8 of a pizza. So the total cost of the pizza can be done by doing this. Or by multiplying 95 cents times 8, which I know that's what you're all going to do to actually solve it. But this is the way of using a variable to indicate that 1/8 of a pizza was 95 cents. If you took this amount, multiplied it by 8, you would have the actual pizza cost for the big pizza. 31. So a train traveled. So rate times time equals distance. Whenever you hear trains, cars, miles, or kilometers, you're probably dealing with rate times time equals distance. Looking at number 31, what information do they give you? Do they give you the rate, the time, or the distance? Which two pieces do they give you? What do you think? They give us distance. Distance, which is 462 kilometers. They also give us a rate, but they do not give us the time. 132 kilometers per hour times whatever the amount of hours will give us the 462 miles that our choo-choo train outside traveled, or the rate it traveled. Last one, 33. 33. I don't know how many of you have ever seen architectural plans, but if a designer is planning a house, they don't draw it as big as your house. They shrink it down by a certain amount. It's generally shown a certain percentage of the real size. In this case, the drawing is 1/100th of the actual size according to the data they're giving us. 1/100th of the length is what we really want to talk about. 1/100th of the actual length is equivalent to 8.5. Okay, they tell us the length of the drawing is 8.5 inches. So 1/100th of the actual length of the room itself is 8.5 inches. Okay, 1/100th of the actual room is 8.5 inches. This would be your equation used to solve that. Today you're only doing 24 through 34 evens.